Okay, so cash value of a lottery jackpot. So this particular question, it says find find the cash value rather of the following lottery jackpot. The yearly jackpot payments begin immediately, so that's key. And then it says assume the lottery can invest at the given interest rate. So it's a $17 million jackpot, 6% interest, and 20 annual payments. That should say payments. So here's the thing: if we note a couple of things that we notice when we're looking, when we're trying to find the cash value, basically we need to find the present value of. I'm going to put present value is what we're looking for. I'm going to say that's equivalent to the cash value. Okay. The reason why you want to find the present value is if they decide to select 20 annual payments, this present value is going to tell the lottery what they need to invest with 6% interest in order to make those 20 annual payments. Now, if the person chooses the lump sum payment, this present value will also tell them how much they can give them right now as a lump sum payment. This is how much you can get right now. And that would be equivalent if we submitted 20 annual payments. Okay, so that's what that is. The other thing I saw is where it says begin immediately. So that's an annuity due. Okay, so this is, what do I want to say? I want to say payments begin immediately. Lottery payments are like an annuity. If you haven't seen my lecture video on annuities, go back and watch that. But you'll notice when you get annual payments, they're the same across the time. Remember, that's the type of annuity. And since the payments will begin immediately, okay, that's an annuity due. And that's important because you want to make sure that you use the right formula. And then, of course, it says that there were annual payments because there's 20 annual payments. So we know that the compounding period, depending on what formula you use, I'm using the one that has M, that is compounded annually. Okay, so the payments are, I'm going to put compounded annually. Okay, so just some things that I noticed. So let's write down what we know. Now because this is an annuity due and we need to find the present value, that's going to be a particular formula. So let me write that formula down. I'm going to write that in blue. Now, some textbooks will call present value, they'll have it like just a P, and then some with payments, they'll use an M. Just know the formula is still the same. You just have to make sure you label what they're calling payment and then what they're calling present value and what they're calling interest and all of that. So for this sake, this is the formula that I'm using, but the concept should still be the same. Now, it's hard to memorize these formulas unless you're using them all the time, which I don't think anybody is unless you're studying for something. So make sure you have a formula sheet where you have these written down so it makes it easier to remember. So let me rewrite that. That's a minus. Make sure that's, there we go. So as you can see from this formula, there's some pieces that we need, right? We need the payment. We need to find our I and we need to find our N. Now they gave us all the information that we need. So I'm going to just write those down. So our payment, if it's a 17 million jackpot, well, that's the total jackpot, right? And they want it as 20 annual payments. So if I divide this by 20, that's going to give me 850,000 if you put that in your calculator. Okay, so that's going to be the total amount of the payments. So I don't want you to think that the 17,000 is the payment, because the 17,000 is not the payment. The 17,000 is the total of the jackpot. Okay, so that's what we're going to use for payment. Your I is your rate divided by your compounding periods. Okay, so our rate was 6%. Let me bring that down so you can see it. Our rate was 6%. Okay, so that if we write that as a decimal, which you should, don't forget to write those as decimals. So that's going to be 0.06. and it's compounded annually because it's 20 annual payments. Okay, and they said yearly jackpot payments. Okay, so compounded annually. So 0.06 divided by 1 is just going to be 0.06. And then your N is your compounding periods times your time. Now you're like, okay, well, what's our time period? Well, it's going to be 20 years because there's 20 annual payments. So that's going to be 20 years. So if I were to write that, which I didn't, I'm going to put my time is 20 years. Okay, so we have this, we have this, we have this, and we have this, just the notes that we kind of jotted down. Okay, so this is going to be 1 because it's compounded annually times 20. So our N is going to be 20. So now we have all the pieces that we need, right? We have our payment, we have our interest. So I'm going to say we have our payment, we have our interest, and now we have our time period, our complete time period of the for this annuity due. Okay, and then we have our formula. This is the formula for the present value of an annuity due, to find what the cash value is. How much do they need right now in order to make those 20 annual payments, if they choose to make the annual payments, or if they want a lump sum. So let's fill in, plug and chug, right? Okay, so let's plug and chug. Let me scroll this down. Hopefully that's okay because we have all our pieces right here. Okay, so I'm going to plug and chug. So our present value is equal to 850,000, and I'm just going to fill in the pieces. And if you follow my lectures, you know I like to show all of the steps because I don't want people to be like, oh, how did you get that? How did you get that? How did you get that? I want you to see how I got it. So that's 20 minus 1, right? All over I. Okay, so we have everything filled in now. It matches our equation. So now let's start doing the math, okay? So I'm just going to walk through this. In your calculator, you want to make sure you do this first, and then you're going to raise it to that power, and then you're going to subtract the 1. Okay, so that's how I'm going to work it. So this is going to be 1 minus 1.06 because I added it, and that's going to be to the negative 19 divided by 0.06. Do y'all see what I did there? Okay, I did this first. This was negative 19, and then the minus 1. So now in your calculator, you're going to do this part. And when you put that in your calculator, see what I got. You should get 1 minus, this is going to be 0.33051301. Try to keep at least 8 decimal places, because if you round too soon, you might run the risk of not matching the answer that you're looking for. You'll probably be off by a couple of dollars. Okay, so if you can keep at least 8 decimal places, keep at least 8 decimal places. So now in your calculator, you're going to do this part. Okay, and when you put that in your calculator, you should get 0.66948699, and then you're going to divide that by 0.06. Okay, so we're still following the steps. So now you're going to put this in your calculator. Okay, so we're getting close to the end. So 850. And when you put that in your calculator, you should get 11.15811,649. Okay, so now continuing to follow, you're going to do this in your calculator, and then you're going to add the 850. Okay, so do this first, and then add the 850 second. When you multiply those two, move that up a little bit, you should get this long number, 94843 990.18. Ooh, okay. And then go ahead and add, well, let me leave that so you can see the whole thing. Go ahead and add these two together. And when you add those two together, you get 10, 3, 3, 4. Okay, so that's going to be 10 million. 399.02. So that would be the present value or the cash value. Okay, so this is the cash value of the lottery jackpot. So what that means is the lottery would need to deposit, they could deposit this into an account that pays 6% interest, and then they would be able to fulfill the 20 annual payments. Or if the individual wanted a lump sum, this would be their lump sum payment because it's going to be equivalent to them getting the 20 annual payments. So the lump sum is smaller than investing it, which makes sense because remember with compound interest, you get more back on your money. So yeah, so it just depends on where you're at, if you would prefer for them to divide it by 20 or if you want your cash up front now. All right, let me know where you have questions on this one.